Very good afternoon to all viewers. Myself Manish Sharma. I am a research scholar from Manav Rachna International Institute of Research and Studies in Faridabad, presenting a lecture on the subject computer organization. The topic of my lecture is instruction cycle. Basically, in instruction cycle, the execution of the instruction being performed by the processor. The execution of instruction is being performed in a sequential procedure. This sequence of instruction execution is different from the sequence of instruction that are written by the user in the program. The processor executes each instruction in the program sequentially. In instruction cycle, basically the processor fetches the instruction from the memory, then the instruction being stored in the instruction register, and program counter is being incremented by 1. Then decode cycle will be performed. In this, the instruction is being decoded by the decoder to find out the output, basically what is to be done in the instruction. Then the last step is the execution of the instruction. That in the execution cycle, basically the instruction being executed. We are coming to the slide of next slide. There is table of contents. First is introduction, registers involved, flowchart of instruction cycle, fetch cycle, indirect cycle, decode cycle, execute cycle. First slide is introduction. In this instruction cycle, each machine instruction needed a sequence of action to be performed. This series of action, this series of tasks that is being performed to execute the instructions are known as instruction cycle. Each machine instructions has following cycles. First is fetch cycle, in which the instruction is being fetched by the processor from the memory. Indirect cycle, in this cycle, the memory address of the operands is being fetched by the processor from the memory. Third is decode cycle, in which the instruction is being decoded by the decoder to understand what is to be done. Fourth is execute cycle, in which the decoded instruction is being executed to give the result to the user. Next slide, registers involved. In this instruction cycle, basically 4 registers are being involved. First is memory address register, second buffer register, program counter, instruction register. In memory address register, it is connected to the address part of the system bus. Memory address register specify the address in memory, the location in memory where the read or write operation is being performed. Buffer register is connected to the data lines of the system bus. Buffer registers specify the value that is stored in the memory is being performed, is used for the read operation. Third is program counter. It is a 16-bit register that holds the address of next instruction to be executed. Fourth is instruction register that holds the last instruction to be fetched. In next slide, this slide shows the flowchart of instruction cycle. Basically, in this flowchart, first step is to transfer the contents of program counter to the memory address register. Next, transfer the contents or data of memory at value at location memory address to the instruction register. The data is being copied to the instruction register. PC is being incremented by 1 to prepare for the next fetch. Next is instruction being decoded, and the rightmost 12 bits of instruction register are being placed into the memory address register. The leftmost 4 bits of instruction registers are being decoded to find the opcode, and so that the machine will understand what operation to be performed in the instruction. Then the condition arrives in instruction needs operand. If this is requirement, if there is a requirement of operand in the instruction, the contents of memory are being copied to the memory bus register. Then the instruction will be executed. If instruction needs no operand, then the instruction will be executed and the process will be end. Next slide, fetch cycle. In this fetch cycle, the processor fetches the instruction from the main memory. PC is being loaded PC is being loaded with the memory address of the next instruction to be fetched. In the first step, the contents of PC are being transferred to the memory address register. Memory address register is connected with the address line of the system bus. Then the control unit issues the read command. The result will be appear in the data bus. Then the contents of data bus are being transferred to the buffer register. The contents of buffer register are being transferred to the instruction register. Then PC is incremented by 1 to be prepared for the next fetch. These are the steps involved that I have been explained. These are the micro operations involved in the fetch cycle. First micro operation involved the content of program counter will be transferred to the memory address register. From memory, the content, that value will be transferred to the buffer register. The contents of memory buffer register are being transferred to the instruction register. Then PC is incremented by 1 to prepare for the next fetch. Second is indirect cycle. In this indirect cycle, the processor fetches the memory address of the operands for the execution of instruction. If there is no memory address of operand will be involved or being fetched, no execution of instruction will be performed. So the memory address of operands is very necessary for the execution of instruction. This cycle is used to fetch the address of operands. The steps involved in this cycle are as follows. The address part, the location part of the instruction register are being transferred to the buffer register. Then the buffer register is connected to the system bus, to the data the data bus of the system bus. The control unit issues the read commands and the result will be appear on the address bus. The outputs that has been shown by the address bus is transferred to the memory address register. The contents of the memory address registers are being transferred to the instruction register. This has been shown. The contents of memory are being moved to the address register. The address part of instruction register are being moved to the instruction register address part. The micro operations of this cycle are being shown in the next slide. Is the next slide. Micro operation of indirect cycle are: first micro operation, the address part of instruction register are being transferred to the address part of memory address register. From memory, the address has been fetched and transferred to the memory address register. The address part of memory address register is transferred to the address part of the instruction register. Next cycle is the decode cycle, in which the instruction being fetched is being decoded into the machine language so that machine will able to understand what is to be performed in the instruction. In this decode cycle, there is the following steps involved. The rightmost 12 bits of instruction register are being transferred to the memory address register. Then the leftmost 4 bits, then the leftmost 4 bits of instruction registers are being decoded to find out the opcode. After decoding the leftmost 4 bit, is the micro operation has been shown. Decode instruction register leftmost 4 bits. In this micro operation, the instruction being decoded and machine try to understand what is performed in this cycle and this instruction so that this instruction will be executed. There are the micro operations involved in this cycle. First micro operation, the rightmost 12 bits of instruction register are being placed in the memory address register. In second micro operation, the leftmost 4 bits of instruction register are being decoded to find out the opcode. Next cycle is the execute cycle. This cycle is used to execute the decoded instruction. Steps involved in this cycle are as follows. Utilize the location in the memory address register to go to the memory to get the content. Placing the content in the memory buffer register, and this process is shown by the micro operation below. The location in memory address register, the data stored at location memory address register is being transferred to the memory buffer register, and the content stored in the memory buffer register are being executed. The instruction being stored in the memory buffer register is being executed. Thank you. A special thanks to all the viewers for giving their valuable time to view this lecture. Thanks a lot.